This project is the best thing I've done in school.
I felt like an engineer for the first time in my life.
We've learned more from this project than from any class could ever offer.
These low-emission hybrid electric vehicles, or HEVs, are the culmination of nearly 2 years of creative effort by engineering students at 30 universities across North America. They'll compete in Ford's Hybrid Electric Vehicle Challenge for over $75,000 in prize money. This electric rivalry is run in 2 categories. 18 vehicles are based on Escort station wagons. This is the conversion class. Another 12 vehicles are built from a clean sheet of paper. This is the ground-up class. Vehicles must be capable of running with electric power only. This is known as Zero Emissions Vehicle, or ZEV mode. They must also run with a gas, ethanol, or methanol engine. This use of an alternative power source is called Hybrid Electric Vehicle, or HEV mode. All vehicles must meet strict design parameters.
Pretty much the top of the front roll hoop. It goes down to a main number.
Including qualifying trials, the teams and vehicles will spend the next 5 days competing in 11 grueling static and dynamic events, judged by Ford engineers. Some of the major events are an engineering design judging, emissions tests at Ford lab facilities, a range event where vehicles must drive on public roads from Ford's Dearborn Proving Ground to the MIS IndyCar racetrack, an acceleration event, and the commuter challenge on a Ford test track. After 18 months of hard work, it's time for the schools to put what they've learned and built to the test. Their vehicles arrive in Dearborn, and the teams work feverishly to prepare them for the competition events.
We're really happy to be here, and we're looking forward to a tough competition.
We've converted it to a series hybrid drive. Series drive is essentially an electric car that has an onboard gasoline-powered generator.
It's a parallel hybrid electric vehicle. It's got an ethanol-fueled internal combustion engine in the front of the car, driving the front wheels, and the electric motors drive the rear wheels.
We built a practical, marketable vehicle. It's got a reasonable range, reasonable performance, and you could drive it every day. You could sell it tomorrow.
Some teams must overcome early adversity and rush to make repairs. All cars must go through a technical and safety inspection by experienced Ford personnel.
Okay, we're doing the interior and exterior inspection of the vehicle.
Right.
So just kind of stand by the car and help us out a little bit.
It's a hoop that's attached to it.
Got stop lamps, all 3 of them. Backup lamps. All right.
This is our tilt table event. What we're doing here is we're tilting the students' vehicles to 35 degrees to make sure that the center of gravity is okay, the car doesn't tip over. We're looking for battery acid leakage or gasoline leakage or any type of fluid leakage on this event.
Secondary school children participate in guided tours of selected HEV events. Many have also drawn HEV posters and engaged in other challenge activities at their schools.
So part of this program was a secondary education segment in which many of the schools have been deeply involved in involving junior high students and high school students into their program.
I felt very excited and I was very proud of myself to see that I succeeded in the contest. And I was very glad to come out the way I did out of 700 entries for a middle school. I think I did very well. My parents are proud of me too.
Qualifying includes 4 events, starting with a combined acceleration and braking run. The slalom tests steering and lane change abilities. The figure 8 tests lateral stability. The U-turn tests turning radius.
I want to cheer for
The University of Alberta is the first to qualify. Each car that qualifies gets a lightning bolt placed on the silver circle received for passing tech inspection.
We hope you have a pleasant stay here, and we hope you have a safe stay.
Competitors gather at a welcome rally the first evening.
Not that you guys will need to know what they look like, because this is how you're really going to communicate with them, but if I could bring my event marshals out now.
The HEV Challenge is being staged by Ford Team Concept, a group of recent college graduates now working for Ford. The HEV Challenge is their baby, backed by Ford management. In this song, they mirror the competitors' feelings after exhausting efforts preparing their cars.
You ain't gonna need FTC's advice, and there's a car that has to meet tech specs, and we're at the bar, too much to confess. And if HEV turns out to be a mess, we'll drive it off a cliff. Everybody, drive it off a cliff. Drive it off a cliff. Drive it off a cliff.
The competitors also put on skits of their own.
Bruce, where's the drill bit? Where's what? Where's the drill bit? I don't know where the darn drill bit is, Henry. Did you use it last, man? Where's the drill bit? I gave it to Henry. You show him, Mike Scott.
Overnight, some cars are plugged into 110 or 220 amp wall sockets at the recharging station. They'll take on a full charge in preparation for the next day's events. Day 2. The majority of teams labor on their cars to pass tech and safety inspections and to qualify.
We're halfway through qualification, but through our testing and stuff, we feel that we're going to have a really good chance of winning. We're really pleased with our design.
We're breaking new ground all the time. Our controller strategy has never been done before, so we're very excited about that.
I'm the driver of our car, and today we qualified first so far, and that was quite an experience. Quite different than what I'm used to, but the car really handles well.
It's a great car in theory. We're having some problems getting it to work the way we want it to work, but at this point it's running, and somewhat happy with that.
Higher currents, felt better? Try it ZEV a couple of times, see what you think.
It's still got a few bugs that need to be ironed out. It works great as an electric vehicle right now. The hybrid portion of it still needs some work, but given a little bit more time, it's going to be a very decently running automobile.
Our vehicle has very good power in both drives, both ZEV and HEV mode. We felt that a car wouldn't be pleasing to the customer if it was wimpy in any drive, so we backed it with power.
Ford President Red Poling looks at the Michigan State Ground Up entry. At the engineering design event, the quality of design and construction is judged. Day 3. All vehicles undergo emissions testing at Ford lab facilities for tailpipe emissions that affect air quality. They are checked for emissions of hydrocarbons, nitrogen oxide, and carbon monoxide. Ford technicians put each car through a test cycle using sophisticated gas chromatograph analysis and computerized programs. At the HEV Drivers School, former race driver and driving school owner Bob Bondurant teaches competitors safe driving strategies and some go fast, go smooth tricks.
Give me a 3-9 hand position right now, everyone. Take your hands out and tighten, and hands and arms shoulder tighten as tight as you can and steer with me. Real tight. Okay, now take a deep breath with me. Now try it. What do you notice different? A little easier?
Day 4. Teams have worked overnight with little sleep to prepare their entries for the range event. Cars start at Ford's Dearborn Proving Ground with 20 laps in electric-only mode. Then they drive 80 miles on public streets and highways, followed by support vehicles. The goal of this event is to test the range of the vehicles in both hybrid electric and zero emissions modes. After the first leg of their journey on public roads, the cars make a pit stop for lunch. It's located at the Livonia Powertrain and Transmission Plant, where they're met by an enthusiastic crowd.
So far, I think we've got about 14 cars in here already in the past hour. I think they're doing really great. They must be durable, they're making it over the roads.
The motor's not heating up, and the car's running pretty well.
We're just checking some of our fuses because our instrumentation, one of the instruments wasn't giving us the correct reading. We just wanted to see if we had blown some fuses.
What do we got here?
I think this is a great way to actually get practical hands-on experience and apply a lot of the theory and knowledge that you learn in the classroom to an actual real-world engineering exercise.
You can see from the people that have turned out to watch the event, I think it has a positive morale impact on all of our employees to see that we are able to support these programs, and that they do have a lot of enthusiasm.
After a run to the Environmental Protection Agency in Ann Arbor, the cars trek farther west to Michigan International Speedway, home of kart IndyCar racing. At the MIS staging area, cars wait for track entry times. They'll do laps around the 2-mile super speedway to gather mileage and points in this timed event.
You should try 3, 2, 1, start. Go. Go.
Almost all the universities have indicated to us this is unique. They have never had the EE departments and the ME departments work together, and this is just an absolute unique experience to the schools with having the two departments work together.
Some strong contenders are emerging in the HEV Challenge in both classes, but there's still another day of events before the winners can be declared.
One of the best things about this project was it gave engineering students a real-world project where they can learn valuable skills that are necessary to be successful in industry.
I think it's an excellent hands-on experience. I know I can say for the 25 students on my team, we've learned more from this project than from any class could ever offer.
What's different from other classes with smaller projects is that you've got all the different teams that must integrate together in communications, and this, what one person builds won't fit with what the next guy builds, and that's the major part of what we've learned with this, is how to make everything fit and work together. So it's been incredibly valuable.
We've gone out and we've designed and built the car from the ground up. We've had to go out and contact suppliers and track down parts and resolve problems when we couldn't get the parts we wanted. We've applied things we've learned in school that you can't really get out of a textbook to a real engineering situation.
Each car gets the checkered flag as it completes the range event. Day 5 is Family Day. Friends, family, and schoolmates are invited to Ford's Dearborn Proving Grounds to witness this final day of competitive events. They also take part in other activities designed for their enjoyment. Out on the track, the acceleration event tests a vehicle's ability to accelerate from a standing start over a 100-meter distance. This simulates a start from a traffic light in an urban environment. Each vehicle performs 2 runs, one in ZEV mode, the other in HEV mode. Now the competitors wait in a staging area for clearance to begin the final event, the Commuter Challenge. Held on the Dearborn Proving Ground ride and handling track, the Commuter Challenge uses a modified course to keep running speeds consistent with an urban environment. This event tests the vehicle's ability to negotiate a simulated commuter trip to work and back. Stop signs, tight corners, and surrounding traffic challenge the HEVs. 2 sessions of 10 laps each simulate a drive from the suburbs to a city center and then a return trip. The vehicles begin with 5 laps in HEV mode. Switch to ZEV mode for the middle 10 laps, then switch back to HEV for the final 5 laps.
We learned about how to engineer a car, what it actually takes, and how much work it actually is involved in putting a vehicle like this together.
This project is the best thing I've done in school. It's been a major part of my education, and I wouldn't trade it for anything.
I felt like an engineer for the first time in my life. I've really tried to teach to them engineering principles and how they affect the real world, how they apply to the real world, and I think that's something that the universities need to work on a little bit, and I'm hoping to fill that void a little bit for that.
It's going to force battery technology to come along quickly, and of course projects like this are going to really help with that. I think it's only a matter of time before it happens in Canada as well, so that's one of the reasons why we've been so happy to participate in it.
And now the milestone everyone has been aiming for all week, the awards ceremony.
Thank you all for participating in this event. From the perspective of the management, at least at Ford, we've all considered it a great success. We hope you have enjoyed the efforts that you've made, and I'm sure that you will find in the future that it was a good experience for all of you. Thank you very much.
First place, Roundup Class winner is Cornell.
We had some steering problems on 2 different occasions, and we almost dropped out. But we were able to bring it back together again and ended up winning the Commuter Challenge event. And I think that's what really put us over the top.
One of the reasons we survived was because Wisconsin lent us their welder.
Yes, Wisconsin-Madison deserves a lot of credit.
First place, conversion class, goes to the University of Alberta.
I'm still amazed that we've all been able to pull together, and as little as 2 weeks ago we were still having problems with our coupling system. We blew up about 3 or 4 of our chargers. We developed our own charger, so boy, we had a whole lot of problems, and we overcame them all.
Here are the top 5 overall winners in the ground-up class of the Hybrid Electric Vehicle Challenge.
The 5th place finish, we were hoping to do a little bit better, but it was overall, we think we did about as good as we could. It was a great experience. Just to be in the challenge and to get a vehicle here was a big accomplishment for our school. And the whole team did a great job.
We learned that there's an awful lot to this. Everything has to be motivated together. Everybody has to motivate each other and bring each other up. All in all, it was very good competition.
The competitors were great. The cars were all great. Even the schools that built them from the ground up, so many of them survived. It's unbelievable.
These are the top 5 overall winners in the conversion class, which includes 2 teams from Canada.
This money that we've won here and the work that we've done and the processes that we're going to be using towards next year's project will definitely be here to come back and hopefully win first place at the HEV Challenge next year.
We knew we had a good chance because we had a solid design. Then we ran into a bit of problems with our Fisher alternator, which wasn't producing what it was supposed to. But at the end, we overcome those problems. Since we were running a series parallel configuration, we managed just to push on and place 3rd, which we're very happy about.
I think the caliber of the competitors was extremely high. Just to create a vehicle that is extremely complicated as a hybrid vehicle is an incredible job.
In reality, all who participated in the challenge are winners in what has been called a mind sport played out in the real world.
Everybody seemed to work within the school has worked a lot better than I thought. I thought there'd be like this strict competition, don't talk to the enemy, but everybody was really cool. A good spirit.
You could go into the other pits and look at the other cars and they'd discuss their designs. It was a good camaraderie.
It was just a big job getting this whole thing to come together, and then once we got here we had a lot of work to do after hours, just getting the car, keeping it together while we were getting ready to compete.
Our original concept was to create something that was exciting for students, something that would take them beyond the classroom, something that would enhance our relations with the schools, and also demonstrate to the schools that we work with government and we work with Society of Automotive Engineers.
It shows that the people of our generation, young people here at the engineering colleges and the teams here, are committed to a cleaner environment and cleaning up the air and energy conservation as well.
It's what you learn and not if you win. It's what you learn not if you win. It's what you learn not if you win. It's what you learn not if you win.